Is there life on Mars? Oh, look, there it is. There's evidence of ancient Martians.
Here it is. Without becoming like too nerdy in this.
I think this is the place to be.
I guess. But Perseverance has basically found...
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm Ed Kellon-Turner.
And I'm Dhara Patel.
Coming up today, this is not a drill. NASA have discovered signs of life on Mars. Or have they? We are going to investigate that today, as well as a bit of the history of Martian exploration and find out what we can learn from these new findings. But first, let's talk about the things that have caught our eyes. Those space wows that have been in the news this week. Dhara, have you got one to start us off with?
I have. So this one, actually, I came across today as we're recording. So it would only be a couple of days old when people are hearing this. But the headline was that the sun is waking up and NASA scientists don't know why.
Okay, I think you're going to have to delve a little bit more than just that, though.
Yes.
What is it, rising or something?
Exactly. So it doesn't give much, but it's enough to cause a little bit of a stir. So the sun doesn't turn on and off. It's not the fact that, it's waking up from a long snooze, but it's looking at what we call solar activity. So I think in a previous episode, me and you talked about the solar Parker probe.
Yep.
We talked about the sun and its activity. And we mentioned that the sun goes through an 11-year cycle of activity. So every 11 years, it goes through a period of very high activity and then low activity. And we know that during high solar activity, or what we call solar maximum, we get this huge release of solar energy. We get more solar flares, which is, intense bursts of radiation from the sun. We get these huge, like CMEs, coronal mass ejections, which are huge, like bubbles of plasma or superheated gas emanating across our solar system that can interact with the Earth.
Yeah, and of course, we need to know what's going on with these because they affect us here on Earth, they affect our satellites, so we actually do really need to keep track of what's going on with the sun with these big events like that.
Exactly, and actually, the sun has been up in the sky as long as people have looked up, but it's only really since the 1600s that we've been recording solar activity. So from the invention of the telescope and us being able to look at things like sunspots, and sunspots are kind of related to solar activity, we had records being built up. So we know this 11-year cycle exists, but actually amidst these cycles of 11 years, we've seen prolonged activity of kind of low amounts of solar activity. So take ourselves back to 1645, and there were a few decades there where the sun kind of went really quiet. And then again in 1790, for a period of about 40 years, the sun went quiet again, and we're not really sure why. And then more recently, in 1980, up until about 2008, the sun was getting really quiet again. And so we expected that it was on this kind of trajectory of low activity.
Yeah.
But the recent research has shown that since 2008, all the signs are pointing to the fact that the sun's activity is increasing, which goes back to that headline of the sun is waking up, and we don't understand why. The trend seems to suggest that it should be getting quieter, but actually it's really waking up. And this data came from two previous NASA missions, which were launched in like the 1990s that have been looking at solar activity, and it's from that we've built up this record. And you talked about this idea that actually we need to understand the sun because it affects life here on Earth. So we can get things like power grids cutting out. It can lead to like radio blackouts in communication. It can lead to our GPS going haywire. And that's because those charged particles from the sun, they interact with the Earth's magnetic field, and they can also interact with the electronics in the satellites that are orbiting the Earth that provide these facilities to us. So we're not really sure why this is happening, and we know about the 11-year cycle, but we're not really sure about why these prolonged, decade-long kind of lower activity periods actually happen. But we need to make sure that we're trying to understand why, because we know it affects our lives here on Earth. So actually next week, NASA are launching 2 more missions to look at the sun. One is called IMAP, which stands for Interstellar Mapping and Acceleration Probe. And the others is called the Caruthers Geocorona Observatory. And if all goes to plan, they should be launching on Tuesday, the 23rd of September.
Excellent. And with a lot of NASA launches, that might even be live streamed. So maybe you at home can actually watch a live launch from what we are talking about today.
So from my blazing sun coming into a kind of out of its slumber perhaps, or waking up. What's your space file for this week?
Yes, we're going from the sun to the moon, but not our moon, a different moon, because Earth has a new moon.
What?
Sort of.
Okay, I knew that was coming.
So what we actually have is what's called a quasi-moon, which is basically a sort of moon. It's called 2025 PN7, and a quasi-moon is a moon, or an object, I should say, an asteroid, that is in orbit around the sun, which is weird because a moon has to be in orbit around, say, a planet or around another asteroid. But the thing is with these quasi-moons, so there's more than just this one, 2025 PN7, but the orbit is actually in sync with planet Earth. So it has an orbital period of pretty much the same as planet Earth, so about a year.
Okay.
And this means that if you were to stare at it for a very long time, over the course of a year, it does sort of look like it is in orbit around planet Earth, sort of. It actually traces out this weird kind of looking bean shape in the night sky.
Okay.
So it's sort of in orbit around planet Earth, but actually if you were to look much further away, it's in no way in orbit around the planet Earth, i.e. a quasi-moon. Now, what's really interesting about this object is we think it's actually been a quasi-moon for about 60 years.
Okay.
So why haven't we discovered it before? Why haven't we known about this object? It's 19 meters across.
I was going to say, is it because it's really small and we've just never spotted it?
It's really, really tiny.
Yeah,
And we were talking about this before. It is quite far away. We're talking millions of kilometers away, although no one seems to agree on how far away it is. So I'm just going to say it is very far away, especially for an object that is only 19 meters in diameter. So incredibly difficult to see, not very bright, but we see that it's sort of in orbit around the Earth. It's only going to be in orbit, or again, in this quasi-moon state for about another 60 years, and then it's going to fly off and go into this other weird orbit called a horseshoe orbit. Again, an orbit around the sun, but sort of seems that it's around the Earth. And again, we get loads of these around the solar system.
Okay, so we've temporarily got a new-ish moon?
Sort of. A quasi-moon, we'll keep calling it. But yeah, a sort of moon. Definitely not one that's necessarily going to be visited anytime soon by any lunar landers, people landing on moons. Quite difficult to make steps on something only 19 meters across.
Yes, that's quite small.
But we are going to move on now to our actual topic, what we talked about right at the start, what we hinted at, life on Mars. Now, if you were to ask David Bowie, he was also wondering this question, is there life on Mars? Well, we've sort of been pondering this question for a very, very long time, since basically the invention of the telescope, since we've been looking at Mars. Some of our more ancient astronomers, kind of from the 1600s, 1700s, they were looking at Mars and going, yes, there is life on Mars. There's some structures that I can see. Can you explain a little bit about that?
Yeah, so anyone who's looked up at the night sky may have actually been able to spot Mars, right? So it's a naked eye planet, looks like a tiny little red star in the sky. But you're right, it's only with the sort of birth of modern astronomy in the 1600s, when we started to get the first telescopes being invented, that we actually got to see details on Mars for the very first time. So Galileo Galilei, credited with the invention of the telescope, probably made some of the first observations of Mars, seeing it for more than just that red dot of light in the sky. We also had other scientists like Christian Huygens. He was able to actually draw a sketch of Mars based on his telescopic observations, but noticed that it had dark patches on it. So almost like when we see the moon and we see the mare, the dark patches, he noticed that actually Mars had a similar thing going on.
And I suppose those mare in Latin literally means seas and oceans, so we used to sort of think maybe there's water on the moon in those dark patches. So
exactly.
A similar thing going on.
We had other scientists as well, so people like Giovanni Cassini. He measured things like the rotation period of Mars, so how quickly it spins on its axis, and noted that actually it's very similar to the Earth.
Yeah.
So Mars only takes a little bit longer to rotate on its axis.
Less than an hour longer, isn't it?
Yeah, it's not very different at all. So these are all kind of lining up with, okay, well, Earth and Mars might be a little bit similar. William Herschel, a famous British astronomer, he observed the polar ice caps on Mars. So again, if you've got a powerful enough telescope, you can actually see these for yourself in the night sky, these kind of white regions towards the top and the bottom of Mars.
Polar ice caps, Earth has polar ice caps made out of water.
Exactly.
Excellent, fantastic, needed
So it's
for life.
all building on that. And then we have people like Giovanni Schiaparelli. He reported seeing what we call canali on Mars. And I think we've talked about this before. Looking through some of those very first telescopes, there appeared to be these kind of like dark lines, or what we call channels, but it kind of got mistranslated. So
yes, canali means channels,
yes,
right, in Italian.
but we kind of translated it to mean canals, and that kind of inspired people like Percival Lovell to popularize this idea that there may be intelligent Martians that are building these canals to take water from the poles and bring it to the equator, where it might be more habitable or hospitable to live on
Irrigating
Mars.
their kind of livestock and all their plants and everything like that.
Exactly. So very similar to Earth-like life, these engineering kind of facets that might have been added in. So all of these observations from like the 16, 17, 1800s by all these different scientists raised the idea of this speculation of habitability on Mars, the idea that maybe life could exist there. But then we get to the early 1900s.
Yeah, let's pop that bubble now, I think.
So when we had some of those first telescopes being improved, what we realized is that those channels, or those canali, were actually fragments or kind of artifacts of the telescope's lens. So with the lens not being perfectly kind of smoothed out, you got these like essentially dark lines appearing on the telescopes. And when we made better telescopes, those lines disappeared. So it went to show that actually those canals weren't actually on Mars. They were just a result of the poor optics that were being used in the early observations. We also had things like H.G. Wells writing things like War of the Worlds, and, you know, being inspired this idea of like hostile Martians. Yeah. That didn't aid the fact, but also the idea of using techniques like spectroscopy. So this is a scientific technique where we basically look at the light that may come from an object or be reflected from an object. And if you split that light out, you get essentially a rainbow or a spectrum, but you might see dark lines appearing on it. And those lines are where light of a specific wavelength or a specific color have been absorbed by whatever is out there in space.
Yeah, and those dark lines are very specific to kind of whatever gas there is, for example.
Exactly. And so we started realizing that actually Mars's atmosphere was way too thin and way too dry to actually have any sort of like lush Martian civilization on there. So the bubbles started popping in the early 1900s, but you still had people that were sort of being excited by this idea of perhaps there still could be Martians. And I think we put the nail in the coffin at the dawn of the space age when we
actually go there to Mars.
The first missions to Mars. So I think the first mission to Mars was a Mariner 4 mission, I think it was.
I believe so, yeah, the first successful one.
And it flew by Mars, and it basically revealed this is a barren place full of craters. There is no hope of any advanced life here. And kind of successive Mariner missions also showed things like volcanoes and canyons and perhaps dried riverbeds.
Yeah.
And so it led to that question of perhaps Mars once had water. And I think at that point is when we changed from this public imagination of like intelligent Martian civilization to more so maybe it's microbial life that we might find on Mars.
Yeah, and we talk about the fact that, well, pretty much if there are alien life out there anywhere in the solar system and beyond, the most likely thing it's going to be is microbial, kind of single-celled or maybe multi-celled organisms, teeny tiny ones that are able to survive really harsh conditions, things like extremophiles, that may have been on Mars back when, as you say, back when it had liquid water and forming those, well, kind of speaking of those channels, dried up riverbeds. Possibly there was life back then is kind of what we're looking at.
Yeah, I think a number of different missions that have been sent by some of the big space agencies around the world, notably NASA, you know, they've looked at things like biosignatures or signs of past life by looking at signs of water. And so if we take ourselves back to perhaps like the mid-1970s and we had like the Viking landers land down, those landers were looking at the specific region they landed in. And while they didn't find any necessary kind of strong evidence for life, they found evidence to suggest that there were a positive result that could suggest like biosignatures. And when we say biosignatures, we're basically talking about biological features that could suggest that they formed from life or life processes.
Yeah, so we're not talking about, say, for example, like dinosaur fossils. We're not talking about a big, massive skeleton that, Vikings landed near and gone, oh, look, there it is. There's evidence of ancient Martians.
Here it is.
We're talking about kind of what could possibly be an example of life living on Mars.
It's the signs or the markers that give us an indication that maybe life was once here.
Because this is the thing, we're really acting as detectives, Martian detectives here. We're taking in all of these clues, and hopefully there's going to be one possible outcome, which is life on Mars. And speaking of the kind of grabbing all of these clues, we found a very, very interesting clue, haven't we, recently, from the Perseverance rover?
Yeah, so the Perseverance rover is NASA's latest rover that has been sent to Mars. But even if we take a step back very quickly, there's things like the Curiosity rover that's been on Mars for quite a while now. I think it was sent in like 2012.
August 2012, I think it was.
And it landed down in a crater. It's been looking at what we call sedimentary rocks. And these are basically rocks similar to we find on Earth that have become layered over time. So we find like deposited material, and it can basically give us a history of what happened in the past, just like we almost have like ice sheets build up year upon year here on Earth, and they kind of track or trap kind of the composition of the atmosphere or what the conditions were like at the time. But Perseverance has basically found what is suggested as the strongest hint of potential life maybe hosted on Mars. And that's quite a strong statement.
Yeah, I think one of the mission scientists I've got written down, this is the most puzzling, complex and potentially important rock ever found, which is a really strong statement, as you say.
A lot to put on a rock, isn't it?
It is a lot, but it's really weird because in all of the articles that I've been reading, they say they found leopard spots and poppy seeds. What are poppies and leopards doing on Mars?
To do with it. I think maybe let's take it back a second and work out, okay, why are these specific features like really important to this rock? So announced in early September, the Perseverance found this rock with potential biosignatures. And what they were looking at is a region around where it landed. So Perseverance landed in the Jezero crater, which is believed to be a dried up, like, lake bed.
Yeah.
And so it has these like channels running into it. Again, not with liquid water, but likely created by streams or rivers of water that deposited into this lake. So this rock was actually found in one of these channels leading into Jezero crater. And it was found in mudstone. And that's really important because things like mudstone and clay are very good at preserving organic material, as opposed to maybe just being exposed to the harsh environment around on Mars.
Really weathering down any evidence
Exactly.
that we might find.
So it's almost like it shields it from anything happening to it. And in these rocks, the particular biosignatures that were found are things like organic materials, so carbon. We're made out of carbon. We're organic substances, but also minerals. And the two particular minerals that the scientists have talked about are iron phosphate, which is given the name vivianite, and also iron sulfide, which is given the name greigite, if I'm pronouncing that correctly.
Hopefully.
So they're basically iron type minerals, but also carbon. So it's this mixture of organic and mineral found together.
Okay.
Now, the combination of these materials together, the fact that you've got organics and also minerals, suggests that it likely formed where you have chemical processes that are changing these particular elements. Now, without becoming like too nerdy in this,
I think this is the place to be. I
guess it's making it, as accessible as possible though. So there's a process known as electron transfer. And the idea is that every atom is made up of the nucleus. So it has the protons and neutrons within the core or the nucleus. And then you've got this like shell of electrons around it. And sometimes when atoms interact with each other, they pull and they nick these electrons off each other. So it's a bit like sharing, I don't know, whatever it is, sweets that you're carrying around in your hand. And the idea is that the iron is actually being oxidized. It's the reason that Mars appears red. That rusty red color is essentially iron oxide. And when it does this, it's basically giving away an electron. So when it becomes oxidized, it's stripping itself of an electron. It becomes iron oxide. But the other minerals that are there, so the things like the phosphate and the sulfide, they're taking these electrons and they're becoming these minerals that we found. So the idea is that we're finding this particular group of chemicals together, and it suggests that there has been a chemical reaction between them because of those different elements or materials that we found.
All right, but saying it's a chemical reaction, we get chemical reactions, I say in nature, as in non-organic kind of chemical reactions. So could this be something that's not a biological process at all, and it's just a natural thing that's happened?
So they have talked about this idea that this isn't conclusive evidence. And actually, given the right conditions, so the right temperatures, the pressures, the environment, the conditions, it may be possible to create these same kind of minerals and organic compositions in a lab or anywhere else. So they could have actually formed from geological processes, so that's the planet moving and reshaping, or other chemical processes that are not biologically related. But going back to this idea of the leopard spots and the poppy seeds on there, this was one of the things that, again, helped us understand that perhaps there is a biological connection to this. So on the rock itself, they basically found what are described as leopard spots. So it's like a dark rim, and then it's got lighter material at the center. So it looks like a leopard spot. Yeah. Poppy seed, because they're very small. That's the size of these tiny little leopard spots on the actual rock. And what they basically inferred from this is that if there was biological life, we know that here on Earth, we need all sorts of materials and minerals, right? So you and I need sulfate in our body. We also need phosphorus in our bodies for things like protein growth and for healthy teeth and bones. And similarly, any growing microbial life will need those elements as well. And if they're feeding on those bits from the rocks, they're taking the sulfur and they're taking the phosphate out of the rocks, then it may leave behind these leopard-like prints where they've got like a lighter center and a darker rim on the outside. And we actually see that with biological processes here on Earth. So it's looking at what happens here on Earth and comparing it to what we've seen on Mars and saying, actually, we see things like this in a rock on Earth and it's caused by biological things. Perhaps the same is happening on Mars. So
we could be looking at a ancient bacteria's dirty plate, is essentially what we're looking at here.
You could put it like that. Yeah, it's feeding, and it needs to do that to grow, just like we do. So it's a metabolic process. It's taking these kind of chemicals in order to create energy for itself to grow.
So it's not definitive evidence of life, but it's a very, very compelling possibility that perhaps this is here. And I mean, I suppose it's very interesting to find this stuff on Mars, one of our closest planets, because, you know, if you extrapolate outwards, there's Earth, it's got life. Mars, maybe we found evidence of life, and you just sort of keep going, maybe there's more and more places out there in the solar system and beyond that there's life. We'll talk about that in a second, but I first just want to kind of talk about the fact that we have a mission that was possibly going to bring samples back to Earth, the Mars Sample Return Mission. And I just want to comment on the fact that it's quite sad, actually, that that's really in flux at the moment, whether that's even happening. When we've got kind of this evidence that there is possibly life. We've got it right there.
One of the things that came out of this is that, you know, the researchers have included that whilst Perseverance is a laboratory on Mars, it can only do so much. And we can't conclusively come to any sort of real kind of, is this life signature or not, unless we bring those samples back to the Earth. And the unfortunate thing is that the Mars Sample Return Program that was being proposed by NASA in collaboration with ESA was a very expensive program, and it was taking a lot of time. So yeah, it's a shame that it's at this point been put on halt and we don't really know where that's going. But I should say that there are other countries like China who are looking to bring samples back from Mars. So Perseverance is busy caching and, you know, keeping these samples safe on Mars ready for return. But when we get them back is a completely different question.
Yeah, that'll be a podcast for the far, far future.
A decade later, yeah.
A decade in the future. But let's talk, obviously we talk about Perseverance and general Mars rovers looking at life on Mars, but we've got other missions going out into the solar system or even looking beyond as well. So we've got Europa Clipper, don't we? Well, heading out to Europa, and also JUICE as well, 2 Jupiter missions, right?
Yes, so Europa Clipper launched in 2024, so last October, and it will be arriving at Jupiter in 2030.
Again, another far future podcast episode.
We've got a while to wait. But this NASA mission is essentially there to orbit around Jupiter. But what it will be doing in the process is making almost 50 close flybys of Europa. And Europa is a moon of Jupiter, which we believe has a thick icy crust, but underneath an ocean, a subsurface ocean of very salty liquid water that could have the right conditions for life. So it's a place of really great interest. And JUICE is an ESA mission which was sent the year before, so in 2023. Won't get there until 2031, but it will be supporting that mission. So it will make a couple of flybys of Europa and supporting the Europa Clipper mission.
And then beyond Jupiter, we've got going out to Saturn. We've got the Dragonfly mission going out to one of the moons, Titan. Much different kind of mission. One, it can fly, which is very strange for usual kind of landers. But also the fact that Titan is not a place that's lovely and liquid water and kind of grassy fields or anything like that.
No, it's quite different.
Very, very different. How is it different?
This is one of the missions that I'm very excited about actually in the coming years. So it's not due to launch at the earliest until 2028. And then if it heads towards Saturn, then it'll take about 6 years to get there. So we're waiting even longer until it gets to Titan. Now, Titan is Saturn's largest moon, and it is the only moon in our atmosphere that has a thick atmosphere, which is really important for being able to provide an environment where we think life could potentially exist. But Titan has a thick atmosphere of like mostly nitrogen and methane. And on the surface, we've had a probe land down, the Huygens probe, back in 2004. And it spotted rivers, lakes, channels of not liquid water, but liquid hydrocarbons like methane and ethane. So we might not think that it's the right place for Earth-like life, but the fact that it has a liquid substance on its surface and goes through that liquid cycle of lakes to clouds to precipitation or rain, and it's got a thick atmosphere, maybe there's another type of life that exists there. And having a copter like Ingenuity flying around on Mars, having the Dragonfly mission on Titan, I think is going to reveal some pretty interesting stuff.
And it will also, if that reveals something really interesting, will then change what we're looking with exoplanets. So planets around other stars, because currently we're looking for exoplanets. We're able to actually, you mentioned earlier about spectroscopy, so being able to look far away, seeing what gases are present, looking at their atmospheres. We're currently looking for, we need oxygen, possibly nitrogen, we're looking for water worlds, things like that. But then possibly if we find evidence of actually these kind of biology different biology can exist on Titan, suddenly we can shift our idea of what we can look for.
And that changes, I think, the game in the sense that to date, there are almost 6,000 exoplanets that have been confirmed. So we're almost at the 6,000 mark. And actually, in our solar system, we've got a few hundred moons. Open that up, 6,000 exoplanets. And not all of them are going to be, Earth-like or potentially habitable, but we've got a whole host of different worlds to try and investigate. Exciting times.
And just to finish this little section on is there life on Mars, I'm going to put that
question
to you. No. I'm going to put that question to you. Ooh. Is there life on Mars? Do you think we will find evidence of life on Mars?
I feel like I'm a little hesitant in terms of like there's actual life on Mars right now, but I think there's so much evidence that we look at in terms of like the presence of water on Mars and some of these different biosignatures and compounds and minerals that we find, that I wouldn't be surprised if we found evidence of past life on Mars. We believe Mars was once a watery, more habitable world like the Earth was, and it's just dried up. What's to say that life didn't exist there in the past?
Absolutely. Now, I've got a bit of a weird hot take when it comes to alien life.
Okay.
And I say weird hot take because I actually did part of my degree on looking at exoplanets using spectroscopy to take a look at them. So looking at alien life and things like that. And my hot take is always, does it matter? Because I always say, it doesn't matter. We might find evidence of life on Mars, but it's going to be microbial. So it doesn't matter. We may find evidence of life within our solar system. It's probably single-celled or very small multicell, so it doesn't matter. If we're looking for intelligent life way beyond our solar system, we're never going to be able to talk to them ever, to have an actual proper conversation, because they are going to be hundreds of light years away. So it's going to take hundreds of years for a single text message to get that. So imagine texting your friend once every 100 years. I don't think that's going to constitute a very good conversation. So That's my hot take when it comes
doesn't
to alien
matter.
life.
Okay,
It doesn't really matter. It'll be nice to know, but it doesn't really matter.
We'll agree to disagree there, Ed.
You want to know.
I think it would be cool. And, even if we can't interact with them, just the fact that there's a squiggly little worm roaming around on Mars, I think is pretty exciting stuff.
So we've had our say, but what do you think? Do you think there's alien life on Mars? Comment below to let us know. Every episode, we like to bring you different ways that you can engage with space. Today, we've got a little bit of citizen science. You've heard us talk about Mars. Well, take a look at some clouds on Mars with the Zooniverse, people-powered research. That is linked down below. Dhara, you've got something that you are actually taking part in.
Yes, so I help organise some of our Space Lates events at the National Space Centre, and we've got our last one of the year coming up on the 21st of November, and it's themed all around messages to outer space. So if you want to come and learn about sort of aliens and exoplanets, there'll be a range of lots of hands-on activities and talks from experts around the UK, then do come along. And we also have an additional sleepover. So this is our family sleepover Space Lates event. You can check out information in our description below, and details for bookings will be online on our website very soon.
Thank you for listening to this episode of Space Now. If you liked it, if you enjoyed that, make sure to share it with your friends so they can know what you now know. Dhara, what's coming up next time?
Well, on our next episode, we're going to have Josh, who will be talking to ESA reserve astronaut John McFall. Now, this is a world first in terms of John being the first astronaut with a physical disability. And he will be talking about the training he's been doing, the feasibility study, which is looking at how we can get modifications made for someone with a physical disability to make it possible for them to go on a long duration spaceflight mission. And then he'll also be talking about what's coming up next for him. So a really, really exciting episode, one that is not to be missed.
Yes, that will be absolutely fantastic. So make sure that you like this episode, make sure you subscribe to Space Now, and we will see you next time.